In this presentation, we will learn how to insert a new element in sorted singly linked list. So let's get started. Let's first consider some basics of sorting before moving on further. Sorting means arranging the elements in a particular order. Let me tell you that sorting means arranging the elements in a particular order. Okay, whenever we want to arrange elements in a particular order, we call it sorting. Let us suppose these are the elements we have currently and they are randomly placed over here. Our target is to sort them in ascending order. That means the smallest element will come at the first position, second smallest element must come at the second position, and so on. Let's find out the smallest element over here. You can see that this is the smallest element, right? So let's just take this element and place it in the first position. So we have placed this element in the first position. Now let's just find out the second smallest element. You can see this is the second smallest element. Let's just place it over here. And then we will place this third smallest element over here. Then we will place this fourth smallest element after this 6. And then we can place this 12 after 10. Then 20. Then 21. Then 24. Then we have 44. Then 45. Then 56, and finally 99. You can see that the elements are now placed in ascending order. Okay, the smallest element is at first position and the largest element is at last position. So it is clear that the elements are arranged in a particular order. That's why we can say that these elements are now sorted. Now let's consider the question. Given a sorted singly linked list, let us suppose this is the sorted singly linked list. Because here you can see the elements are arranged in a particular order and that too in ascending order. Your task is to insert the node given below in the above list. What is our task? Our task is to insert the node, this particular node, in this list. Now it is given in the question that our target is to insert this node in this list. This is the only thing given. Let me tell you that this is a sorted singly linked list. Whenever we try to insert a new node in a sorted singly linked list, then we must have to place that element in such a way that it will not affect the order of the elements. This is very important. Here you can see that the first element is 24, second element is 45, third element is 56, and fourth element is 100. If we try to place this 75, this element in this list, then we have to place it after 56, right? Then only you would be able to say that the elements are arranged in ascending order. That is why no other information is given that we have to insert this element after a certain position or before certain position. Only this information is given that we have to insert this node in this list. And we know that we can insert this node after this position only, because we have to maintain the order of the list. Now let's just consider the solution. First, we will declare a temp pointer which must point to the first node of this list because we have to traverse the list. For this purpose, I am keeping this temp pointer in the first position. Now, I have declared one key variable which must contain the data of this particular node. We will use this key variable in our code. I'll show this to you after a moment. So let's just declare this key variable over here. You can see that it is holding this value 75. Then after this, we need this piece of code, that is while temp link not equal to null and temp link data is less than key, temp equal to temp link. This is the whole logic we have to apply in order to traverse the list. Let me tell you what I'm trying to do over here. Here I will compare this key value with the value of the second node first. So 75 is compared with 45. We know that 75 is greater than 45, so we cannot place this node before this node. So we just move on and then we will compare this key value with 56. We know that 75 is greater than 56, so we will not place this node before this node. That is clear. After this, we will compare this key value with this value. We can see that 75 is less than 100. If 75 is less than 100, then this is the place. This is the place where we can put this node. So this is the same logic. While temp link not equal to null, it should be well noted that temp link should not be equal to null. If it is equal to null, then we should stop. That means temp pointer will stop at last node. If let us suppose that instead of 75, we have 102, then temp pointer will stop at last node in that case. Okay. Currently we have this value 75, so our temp pointer will stop at third node. You can see that temp link data is less than key. You can see that temp link data is not less than key. It is not less than key. So we will come outside of this while loop. That means temp pointer will stop at this point. Previously, when temp pointer was pointing to the first node of this list, then at that point we are comparing this value with this value. You can see that temp link data is less than key. Therefore, temp will move towards right. That's why it will move to the second node of the list. And then we will compare the temp link data with key. Again, it is less than key, right? Again, we will move our temp pointer towards right. Now you can see that it is pointing to the third node of the list. Now we will compare temp link data with key. This time temp link data is greater than key. Therefore, we'll come outside of this while loop. That's what we want, okay? We want our temp pointer to stop at this node so that we can place this node after this node. Now, let's just update the links. First, we will update this link. That is, we will update the link part of this node first. New p link must be updated by temp link. Obviously, we will store this address, that is 4000 address over here, so that our new node will point to this node. After this, link part of this node must be updated so that it can point to this node. Isn't that so? And that's it. This is all what we need. And let me tell you that this code is also taking care of the case when the node has to be added at the end of the list. It should be well noted that this particular code is also taking care of this case. That is, when the node has to be added at the end of the linked list. How? You can see that I'm also keeping this condition. Temp link should not be equal to null. Let us suppose instead of 75 we have 102. We know that in that case, temp link data is actually less than the key value, right? So we'll continue. Temp pointer will move towards right, then it will point to this node. After this, we will check this condition. We know that temp link is actually equal to null. So we'll get outside of this while loop. This simply means that temp is pointing to the last node of this list. After this, we will update the link part of this node by temp link. We know that temp link is holding null, so we'll place null over here. After this, we will update the link part of this node so that it can point to this node. This means that new node, this node will get added at the end of the list without any problem. So this code is also taking care of the case when the node has to be added at the end of the linked list. I think this is clear, right? Let us consider the case when the node has to be added at the beginning of the list. Let me tell you that the previous code is not taking care of the case when the node has to be added at the beginning of the list. You have seen that we have started comparing from the second node, okay, not from the first node. That is why our previous code is not taking care of the case when the node has to be added at the beginning of the list. We have to add a separate piece of code for handling that case. For this purpose, I'll put this if construct, that is if head is equal to null or key is less than head data. Okay. If head is equal to null, that means if there is no node in the list, or key is less than head data. Let us suppose that this is the node we want to insert. And this node will get inserted at the beginning of this list because you can see over here that the element is 20, right? And here, this is 24. This will get added at the beginning of this list. No doubt about this. If we want to insert this node at the beginning of this list, then we have to compare this value by this value. For this, we will compare the key by head data. Head is currently pointing to the first node of this list. So we will compare this key, that is this value, with head data. We know that key is less than head data. So we will update the link part of this node so that it can point to this node. After this, we will update our head pointer so that it can point to this node, this new node of the list. And that's it. This is all what we have to do in order to insert a new node at the beginning of the list. Now this case has to be considered separately because we have started comparing the data from the second node itself. This code is different from the code we have seen. Here we have to update our head pointer also, which is different, right? We can't use that code which we have already seen for adding the data at the beginning of the list. Here we have to update our head pointer so that it can point to the new node. So that is why we are keeping a separate code for handling the case of adding the data at the beginning of the list. Now here is the complete code available. You can see that this is insert function, and here it is accepting a head pointer as well as some data. You can see we have a temp pointer, we have a new p pointer. Here I'm allocating memory for the new node, and also I'm assigning data to the data part and null to the link part. That is, we are creating a new node, right? After this key variable has been declared, which has been initialized by data, and then you can see the same piece of code which we have already seen. Finally, we'll return head back to the main function. And that's it. This is all what we have to do. Now let me show the complete code in code blocks. So here is a complete code. We have a struct node for a single linked list. Then we have add to empty function, add attend function for creating the list. We have this insert function which we have seen already, right? After this, we have this print function and main function. In this main function, head pointer is declared, which must be initialized by null. After this, add to empty function is called for creating the first node of the list. And then add attend functions are called 3 times, right? So the list will look like 24, 45, 56 and 100, right? After this, insert function is called, to insert this particular element in this list. After this, print function is called to print the complete list. Let me just execute this code. You can see that this is the complete list: 24, 45, 56, 75 and then 100. Let me just change this to 102 and let's see whether it is working fine or not. You can see that it is working fine. 24, 45, 56, 100 and 102. Let's just change this to 20. You can see that 20 is inserted at the beginning of this list. Isn't that so? So this is a sorted singly linked list. And this program is helping us to insert a new element in the sorted singly linked list. Okay friends, this is it for now. Thank you for watching this presentation.